Hello young learners. We have learnt writing of balanced chemical equations of metals with a number of reagents. Now the question arises, why do metals react in this manner? Let us recall what we learnt about the electronic configuration of elements in class 9th. As you can see that noble gases have a completely filled valence shell, and due to this they show little chemical activity. So we can explain the reactivity of elements as tendency to attain completely filled valence shell. Now have a look at this table. It is outline of a periodic table, which we will discuss in next lesson. Notice the zigzag line over here? Yes, this separates metals which are colored in green, which are all elements on this side of the table, and non-metals which are mostly elements on this side, depicted by yellow color on the right hand side. Have you wondered how a metal and a non-metal are held together in chemical compound? Now let us have a look at the electronic configuration of some of these metals and non-metals, and of course noble gases which are over here. Remember, they are also known as inert gases. Well, you can see on the screen that octet of noble gases is complete. Look, well, can you spot neon, argon, all of them with 8 electrons? Exception is neon. Yes, it gets stable by a duplet itself. They are stable. They do not react. That's why they are inert. And look, what about metals? They have 1, 2 or 3 valence electrons. So how will they complete their octet? And non-metals? They have 5, 6 or 7 valence electrons. Their octet is also not complete. For deeper understanding of the concept, let's consider sodium chloride. Sodium chloride is scientific name, tell me, of what salt? Yes, of table salt that you put in your vegetable curry. Now, this sodium chloride is made up of 2 types of ions, sodium and chloride. I'm sure you want to know why I didn't say chlorine. We will talk about this a little later. Come with me on a small journey of how we go from 2 single atoms to this formation of a molecule. So here, let us start with 2 separate atoms, metal atom and non-metal atom. Let's explore how they become one single compound, sodium chloride. Okay, let's get going. What is the atomic number of sodium? Yes, it's 11. So what its electronic configuration will be? Well, let's see. We have to arrange 11 electrons around the nucleus. So in this atom, let me first arrange with the white circle is 11 protons. In the first shell, we have 2 electrons. Well, this is the next shell. Count the number of electrons here. Well, they are 8. Yes, so 2 and 8. How many more electrons are left to be arranged? Well, 1 more. So here comes the M shell. And note that in this M shell, this is the outermost shell, sodium has just 1 electron. Well, so can you count the number of protons are 11 and count the total number of electrons? They are 11. So you can see that sodium atom has just 1 electron in its outermost shell. Well, here I have used these rounds made of clay. You may even use crumpled used newspaper balls and color them with natural colors or locally available materials. Now, let's see how the chlorine atom looks like. So, what is the atomic number of chlorine? Well, it's 17. So, we have to arrange 17 electrons around the nucleus. So, here is the nucleus with 17 protons and the first shell with 2 electrons. And here comes the second shell, that is, this is K and L. Now, in L, how many electrons are there? See, 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 electrons. And now, in the outermost shell, we have Count the number of electrons. Yes, 7 electrons. So this is 1 electron short of its octet. So this is how the chlorine atom looks like, and it has 17 protons and 17 electrons. So this is electrically neutral. Well, talking of sodium, yes, it can lose the electron from its M shell, and if sodium and chlorine were to react, this electron which is lost by sodium could be taken up by chlorine. So you can see the shifting of the electron from here to here. Well, with this electron gone, now what is the outermost shell of sodium? Yes, its L shell now becomes the outermost shell, and now it has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So, this is no more an atom. It has become an ion, and this ion has 11 protons and 10 electrons. So, because the number of protons are more than electrons, this is a cation. So, now there is +1 net charge. Now, how many protons does chlorine has? 17 protons. But after gaining an electron, this is no more an atom. It has become an ion. Well, so what is this ion called? Yes, it's an ion, and it gets a unit negative charge. Can you tell me why 1 unit of negative charge? Yes, because its nucleus has 17 protons and 18 electrons in its K, L and M shells. Well, so this gives us a chloride anion, that is Cl minus. Now children, you know why it is called chloride? Because it has gained 1 electron and it is an ion. And when it is chlorine atom, we are using the word chlorine. So both these elements can have a give and take relation between them. The sodium transfers 1 electron and chlorine gains 1 electron to become chloride ions. Now, this sodium ion, which is Na plus, and the chloride, which is Cl minus, they both being oppositely charged, attract each other and are held together by strong electrostatic forces of attraction to exist as sodium chloride. Yes, NaCl. Sometimes the children end up writing the formula as Na plus and Cl minus. Well, children, keep it in mind. This is the wrong way of writing, because after they join together, the plus and minus charges cancel each other. So the formula becomes NaCl. So this is the correct way of writing the formula. When you talk of ionic bonding, it does talk of formation of these smaller molecules. But this is just one part of bigger lattice structure, where many smaller units come together. See, these are attracted towards each other. Well, this is the one molecule, this is another, and this is the third one. So here this is one molecule with positive ion and the negative ion held together. This is another one, and this is the third one. So look here, chloride with negative charge will attract another unit of this molecule. So here it goes like this. And what about this? Will it get attracted like this? No. So here the plus and minus go together. So this way sodium chloride will exist not as a single molecule but aggregate of oppositely charged ions like this. So in this sodium chloride crystal lattice, as you can see, in the center is the negative chloride ion, and this is surrounded by 4 positive sodium ions. And see, if we turn, what is here? In the center you find the sodium positive ion, which is surrounded by the negative ions, the chloride. So well, if you slowly turn this crystal lattice, you see how the sodium and chloride ions tightly fitted together. The oppositely charged ions are held very tightly. Look here, by this electrostatic force of attraction. Well, children, you may also engage yourself and make this sodium chloride crystal lattice at home. You may use locally available material, maybe just crumple the used newspaper and join them together with a glue and paint them in the color you like, whatever color is locally available, and just enjoy learning science. Now, tell me, how will you show this in writing? Well, yes, see here, you will write it like this, that Na gives Na plus and it loses one electron. Now keep this electron in mind. This is very, very important. And where does this electron go? Well, the chlorine atom, which is just one electron short of completing its octet, it just takes that electron. Yes, it grabs the electron and becomes chloride ion. And well, how will you show in written, how will you represent the formation of sodium chloride? Look here, Na plus and Cl minus, they are held together to form NaCl. Yes, now let's move ahead and see the formation of one more ionic compound. Now this you are going to develop yourself. This is a little task for you. Okay, so are you ready? So I'm giving you a task of formation of one more ionic compound, that is magnesium chloride. Yes, so see, look here. Magnesium, it loses 2 electrons and forms magnesium ion. And see, look here, it has 2 free electrons. And I told you, no, these free electrons are very, very important. Why? Can you recall? Metals are good conductors. And it is these free electrons which carry the electricity. Interesting, no? And here is the chlorine atom gaining the electron and forming the chloride ion, which you have just done. So here is a worksheet for you, in which I have given you a small hint that yes, this is the magnesium ion, and this magnesium ion, I haven't drawn the electrons here, and these are 2 chloride ions. Again, see, the electrons are missing. Well, this is the task for you. What you will do is, you will place the electrons, maybe with the help of these bindis like this and like this. You may use some colored paper or some colored sketch pen to indicate the electrons around the 2 chloride ions and complete this worksheet. Similarly, do some more tasks, because the more you practice, the more you will become perfect. And why don't you write electron dot structures for sodium, oxygen and magnesium? Can you name the cation and anion present in magnesium chloride? Now let's take the task little further and let me see how you can show your creativity in the formation of sodium oxide and magnesium oxide. So let me see how you think out of box and make colorful dots to complete your task. Okay, now that you have learnt formation of ionic compounds, let's learn about the properties of ionic compounds. Well, why small activity I said? Children, you know. Here I have sample of sodium chloride. Well, from your science laboratory, you can even take potassium iodide or barium chloride or maybe some other salt. And well, look at this. What is the physical state of this salt? You have learnt about ionic compounds, that they are solids and somewhat hard. Now, can you tell me why? Yes, you just now learnt that because of the strong force of attraction between the positive and negative ions, these compounds are generally brittle and they break into pieces when pressure is applied. Now let's engage further. Here I have electric circuit. You may also prepare at home. And remember, you tested the conductivity of metals? Why do metals conduct electricity? Well, put on your thinking cap and you know the answer, I know. Okay, let's explore if metal salts also conduct electricity or not. So let us check. Here I have solid sodium chloride. I'm sure your parents will give happily a little of sodium chloride if you want to test with your own electric circuit. Well, observe what happens when the electrodes are inserted into solid NaCl. Oh, the bulb did not glow. Your investigation has revealed that there is no conduction of electricity in this case. You can tabulate your observations. But in NaCl solution, what happens? Ions move freely and conduct electricity. So can we conclude that ionic compounds conduct electricity in molten state? But the question is, why ions are moving freely? Come on, guess. Yes, the electrostatic forces of attraction between oppositely charged ions are overcome due to the heat. So that is why ions move freely and conduct electricity. Well, children, you may now elaborate and test some other salt samples too in this manner. And it will be interesting to insert electrodes into a cut potato or maybe a cut lemon and see if bulb lights up or not. And what will be your inference about the nature of these compounds? And write down all your findings. And remember, you have to include all in your portfolio. So now you know how metals and non-metals become stable. Okay, so tell me, metals have 1, 2 or 3 valence electrons. So how will they complete their octet? Yes, they lose their electrons to achieve octet. And what about non-metals, which have 5, 6 or 7 valence electrons? Come on, tell me how they complete their octet. Yes, they gain electrons to complete their octet. So, you have learnt that ionic bonds are one type of chemical bonds. And you also learnt that in a chemical compound which has a metal and a non-metal, they are held together by ionic bonds. So, can you give me some more examples of some compounds which are held together by ionic bonds? Well, I'm sure some of you may say magnesium chloride or maybe calcium oxide or lithium chloride. So each one of them has a metal from the left hand side of the periodic table which are connected with a non-metal from the right hand side of the periodic table. So which bonds are there in all of these? Yes, they have ionic bonds, as there are metals and non-metals connected together. You also learnt about the properties of ionic bonds. By use of 5 E's, you engaged yourself, you explored a bit, and you were able to explain also. And well, I am sure you will elaborate your findings when you test many samples. And in the end, you can tabulate and evaluate. And yes, remember to keep all your findings in written format in your report and keep it in the portfolio for revisiting the concepts. This way, not only you will improve your scientific skills, but also language skills and fine art skills. So happy learning, my dear children.